So we're going to just look at the absolute value function. Absolute value function, how does it connect to lines? Well, it's like having two lines coming in and meeting at the point, which is like it makes a V. So the parent graph of this is a V-shaped graph. We'll graph it in just a minute. Absolute value has a V-shaped graph that opens either up or down. So it's just telling you the shape. So it has a V-shaped graph that faces up or down. So we can do that later.
I'm questioning if that's what the answer is. I need a big smart board. And then
So you got that?
yes.
Has a V-shaped graph that opens either up or down. And our goal here is to be able to graph these absolute value functions without making an entire table. Okay, that's the goal. We're going to do the table for the parent graph, but then after that I'm going to show you some translation rules, we call them. You may have done that a little bit in your 8th grade Common Core math. Translation reflection rules.
Oh, yeah.
Translation is this. It's a shift of a graph horizontally, vertically, or both. By the end of this, we'll be able to move it left, right, as well as up and down. Super easy to do once you see it. So a shift of a graph horizontally, vertically, or both. And although we're going to be working with these absolute value functions, what I'm showing you today will work with any functions that you'll learn about in the future. They all follow the same rules. There's actually 6 different rules of reflection and translation. And you'll do this with just different shapes next year in geometry. So actually it's pretty cool. Do all kinds of different shapes.
Yeah. Isn't it like
Artwork even and stuff like that.
Is it like where you
So
just
these are up here.
flop it?
Yeah, that's the
Isn't
reflection.
Isn't there like there's one that it's smaller? What's that?
That's a dilation. Yeah. So you guys did do those. Yes.
I mean, I wasn't there because I did algebra for a year. So when I just got back, they just stuck up there.
Okay. They showed you quickly.
Yeah.
Yeah, it's kind of a neat little feature here. But we could take this graph. We're going to put in as inputs for this one -2, -1, 0, 1, and 2. And then we're going to evaluate it. So first one would be y equals absolute value of -2. And what does that equal?
Isn't that 2?
That's +2. Second one would be y equals absolute value of -1, which is 1. And then it's y equals absolute value of 0, which is 0. And then what's the absolute value of a positive? You change it? A lot of people think to change it. Yeah, it's actually not. Absolute value means take the positive of it, so it's just still 1. And then y equals absolute value of 2, which is 2. So there it is. We plug in the number. Now, this will work on any of the ones I'm giving you today. You can make a table if you want, but our goal is to not have to make the table.
Oh, I see.
There's a trick to it here. So how did I get 2 right here? Right up here?
Yeah.
These symbols, absolute value means take the positive version of -2. So we change it to positive. So we have -2, 2, -1, 1, 0, 0. So it's like a linear equation with a slope of -1, and then it meets another linear equation with a slope of +1, and so it makes what we call a V. So what we're going to do is take that V. This is the parent graph. You're asking what a parent graph is. This is a parent graph for all different translations and reflections of absolute value functions. We're going to take this, we're going to move it up or down, and we'll move it left or right, and then we'll combine the two.
Why do we have to do that?
Well, because what we're learning about on translations for this will work for y equals x squared, y equals, like the trig functions you'll learn about in pre-calculus. It works for 1 over x, it works for exponential functions, all these different functions you're going to study in algebra 2. Not only that, but in geometry you'll learn how to do this with different shapes. So dilations, translations, reflections.
Wouldn't it just be the opposite coordinates?
Opposite coordinates for what? A reflection? Well, sort of.
Move it down.
One of them is you take the opposite of one of them, either the x or y, depending on which reflection you're doing. Yes. But there is a reason why we're doing this. It really does connect to something you're going to be doing later. It kind of connects to lines a little bit. So here, below are the graphs of y equals absolute value of x and y equals absolute value of x minus 2. So the question is, how are these two graphs related?
They just went downward because they both were like.
Yeah, they both are a V, so they're similar in that they both make a V. How are they different? Yeah. Yeah, one's a little more down. We can actually be more specific. We say it's shifted or translated. Shifted is another word for translated. Shifted 2 units down. So this one is shifted 2 units down. And notice how the equation's written. Do you see this up here? It's the parent graph, absolute value of x, minus 2 shifts it 2 units down. How do you think you would shift it 2 units up? Yeah, if you add 2, it would shift it 2 units up. As a matter of fact, this one right here is shifted, not 2 units up, but it looks like 4 units up. So it says, how is the graph at the right related to the graph y equals absolute value of x? It's shifted 4 units up. And that's called a translation. The translation. So as we're looking at these, it's like, well, we don't really need to make a table for the graphs of y equals absolute value of x minus 2 or this graph if we know how to shift it up or down to move the whole thing. Like all points, every one of the points there gets shifted up 2 units from the parent graph. Every one of them. Yeah. You might want to wait here. It's not going to take me long to read this lesson. I know, but you might want to just see what I already know. Okay.
Oh, got you there.
Man, I'll just sit down and you come on up, teacher.
Oh.
Okay, so real quickly. See. What is the graph of y equals absolute value of x plus 2? So my question is, how can we do this without drawing a table? Mathematicians are lazy.
Just put the
Yeah.
Oh, Sarah, you scored.
So the 2 right here is going to be my y-intercept, if you will. Sure. Instead of where it was at 0. It's like if I were to draw a little shadow of the parent graph, it would look, we'll do a dashed line. Here's the parent graph. You don't necessarily need to do this. There's the parent graph. And every point's going to move up 2 units. So this one right here is what we base it off of. Okay, that's Sarah's saying. So she's going to move this up 2 units. You're digging. And then we're going to move this one up 2 units and so forth. Now, just to be accurate on this, notice that the slope is 1 over 1 up, 1 over 1 up, or 1 left, 1 up, 1 left, 1 up, 1 left, 1 up. So our final answer looks like this. And we can, I can erase this. Sometimes in geometry we'll ask you to maybe draw the parent graph, or ask you to draw the parent graph and then draw the new one. But I didn't draw any table, did I? No table.
Now, and by the next one, it's right.
And actually, when you start moving it left or right, if you try to draw the table, it doesn't quite work to just use -2, -1, 0, 1, and 2. I think I mentioned this earlier. You might only get half of this graph, and then you think in your brain, like on that performance test, I think it's just a line. And really it's not. It eventually comes back up. So what about this one? Can you graph the next one here on your own?
Easy.
Easy? Okay. Go for it. I'll come around and see how you're doing. So graph absolute value of x minus 6. See if you can draw that graph based on what we just learned about translation. Where would the new bottom of the V be? And draw it.
Oh, wow.
Wait, what? It would be, it'd be at -6 and it's going to go up. think you guys all have it. Okay, good. So I think you have the idea of moving it up or down. That's actually the easier of the two translations. So if we go to the next page here, now we're going to talk about moving it right or left. Okay. Now, don't write anything down yet. I have to show you this. I think if you see it, it might help to make my case a little better. Say, for example, I picked -2, -1, 0, 1, and 2 in here. So if I plug in -2 right here, I have the absolute value of -2 plus 5, which is 3. Okay, don't write this down yet, guys. Don't write this down. Don't write it down yet. Not yet. Just wait. Just watch. And then here we have -1 plus 5, which is 4.
That's 5.
And then we have 0 plus 5, which is
5.
So 3, 4, 5. And then we have 1 plus 5, which is, and then we have 2 plus 5, which is, and none of them are negative, so we don't really apply the absolute value, so it doesn't make a difference. So what I do is when I go to graph it, don't graph it yet either. Don't graph yet. Just wait. -2, 3. -1, 4. 0, 5. 1, 6, and then I go off the graph. It looks like it's a line. I don't see it making a V, but yet it does. What's happened is it's just shifted over so many units to the left that I'm not getting the other part, and I won't unless I plug in numbers like -6, -7, -8. So to just go and plug in semi-random, they're not really random, but to plug in values for x without really thinking about it is going to be a problem. Okay, it's a big problem. So let's think about it a little bit here. Let's think just a little bit. Try to outsmart this thing, and then we'll see if we can come up with a trick here. Okay, so now you can write this down. Now you can write this down. At what point is this going to hit 0? It's a good guess. You're close. It's not +5, but -5. So I want the middle of my table actually to be -5 here, because then I know I get 0. You with me? We're trying to outsmart this thing. So if I go now, so if -5 is my new middle rather than 0, these would be -6, -7, and this would be negative. Yeah, and so we're smarter here. So if I put in -7 here, -7 plus 5 is equal to the absolute value of -2, which is 2. So that's 2. Then we plug in -6 plus 5, which is the absolute value of -1, which is 1. Yeah. And then we put in, well, that one we already did. So now we have -4 plus 5 equals 1, absolute value of 1, which is 1. So now it's coming back up, and that's 2. So at -5, I'm at 0. -6, I'm at 1. If I added on a -7, I'd be at 2. -4, I'd be at 1. And -3, I'd be at 2. And then I see my little V shape.
Makes sense.
Hopefully it does. So my goal would be to make this a little less painful for you. I mean, does anybody like to do the tables? Plug in all the values? Anybody out there? All right. That's great. So I don't really like to be honest with you. I like to get rid of this table. To get rid of that. I like to just graph it by looking at it, using what I know about translations. So look at this right here. We've got an absolute value of x plus 5, and it moved or shifted 5 left. Take a wild guess as to how much this will shift the parent graph and in which direction.
Quattro.
Shifts 4, and in which direction do you think it will be?
Right.
It will go right. Yeah, shifts 4 right. So when you see a negative inside the absolute value, it will shift positive that many units, and if you see a positive, it will shift negative that many units. So thinking about my parent graph, where's the new bottom of the V going to be on here?
4.
4, 4, 0. And then how am I going to know like what the other points are? It's going to go
Just go up 1 over.
Just
Up
go
one.
up one.
up 1 over 1, up 1 over 1. And then over here, left 1, up 1. So in other words, you don't need the table. If you understand your translation rules, so let's just review here. If the number paired with the x is inside the absolute value, it moves it left or right.
Wait, what?
If the number is inside the absolute value, it moves it left or right. And if it's outside of it, like it was
It moves it up or down.
here, it moves it up or down.
That makes so much more sense because if it's okay, so if it's negative, it goes down.
This one, it's opposite. There's a reason for that. We saw it right here. When we plugged in -5, it made this 0. So it's like you got to think about what number would make this equal 0. We give you a y coordinate of 0. That's why it's opposite, because it's moving the bottom of the v to a different point. So that's actually, those are two translations. They're the horizontal and vertical translations, and then we're not talking about reflections today. Another day we'll talk about that. So that's a quick summary. So as you go through the classwork, I'm hoping I gave you lots of different
1 through
combinations.
16. Oh my.
Yeah, but I want you to see every different combination. A left, a right, an up, and down, and then there's combinations. I'm going to see if you can figure it out in the classwork. What happens if I ask you to do both? I think you can figure it out. So we'll just say y equals absolute value of x looks like this. If I have y equals absolute value of x plus 5, it goes up 5. If I have y equals absolute value of x plus 5 inside, what does it do?
It goes down.
Not no, not here. Not right.
It goes to the middle.
Left 5, yeah. And if you wanted to be even more specific, what if it has? What if it's y equals absolute value of x minus 5? What does it do?
Going down.
It's down 5. And then the other case would be absolute value of x minus 5, and it would go
To the
right 5. And so those are your 4 cases for translations of the paragraph. Y equals absolute value of x. So I said kind of a lot, but I'd like you should be able to do them quickly. Look at your pink sheet. It says what to do.
Oh my gosh.
So you're going to fly through. I think you can get the homework down here.
I got a question.
Let me stop this.
Wait.